Section 5.5, Systems of Inequalities. So now we're still dealing with systems, so two or more, but we're not going to have equations, we're going to have inequalities. So what are the things that are going to be inequalities? We're still going to need to be able to graph lines, parabolas, and circles. Now I'd like for you to do this without a graphing calculator, so you do need to show me some of the work that you're doing and not just typing these things into a graphing calculator. If this was a face-to-face class, which it used to be, I would have you take this test without a graphing calculator and just a scientific calculator. So make sure that you're not just using your graphing calculator to graph these things. So we're going to sketch the graph of an inequality in two variables. So we're going to either have lines, parabolas, or circles. I first would say replace the inequality sign with an equal sign. So let's pretend we have an equal sign, and then sketch the graph just with an equal sign. However, go back and look to see if you have a dashed line or curve. If it's going to be a dashed line or curve, that's if you have a less than symbol or a greater than symbol. Now, if it's going to be a solid line or curve, then that means you're going to have the equal sign underneath. So that means you can use the things on that line or inside or on above or below. So make sure with that inequality, if you have a solid line, you're going to see the less than or equal to or greater than or equal to. Now, a lot of students like to kind of just have a way of guessing on where they shade, and sometimes it works, sometimes it doesn't. So I would say always use a test point. The test point that I always like to choose is 0, 0, as long as I'm not going through 0, 0. And then wherever 0, 0 is, if the point satisfies the original inequality, you're going to shade where that test point was. If it doesn't, then go ahead and shade on the other side. So let's do a little bit of review of how to graph lines, parabolas, and circles, and then we'll get into our system. So if we said sketch the graph of the inequality, again, I would make sure on the test I highlight inequalities because there's a lot more thought process involved. And with that, that means you have to understand if it's solid or dotted and also do some shading. It's not going to tell you to shade, you need to know you shade. So if we're looking at this and we have x less than or equal to 4, we're going to pretend we have an equal sign. So if we pretend we have an equal sign, we're just going to say x equals 4. So again, we'll come back to the inequality in a second. So we're going to go, that's just a vertical line at x equaling 4. Now, is it going to be solid or dotted? Well, it's going to be solid because we had less than or equal to. So we definitely need to have a solid line. So drawing a solid line at x equaling 4. And then we have to know where we shade. Well, how do we know where we shade? Well, we looked for a test point. And the test point that I like to use is 0, 0. We can use 0, 0 as long as we don't go through 0, 0. And we do not. So, plugging in a 0, we only have one variable, so we'll just plug in x being 0. And 0 is less than or equal to 4. So that is true. So I'm going to shade on this side. Alright, so for the next one, we have y being greater than x squared plus 1. Again, let's pretend we have an equal sign. So y equals x squared plus 1. Try not using your calculator. This was a parent function, and all it's going to do is get moved up 1. So let's do -2, -1, 0, 1, and 2. Plugging in -2 squared, we get a 4. And if you want to just go ahead and add in the 1, you could. So -2, 5. When we plug in a -1, we get a 2, we get a 1, a 2, and a 5. So -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. But before you connect them, make sure you realize if it's solid or dotted. And this is going to be a dotted one. So make sure you have a dotted parabola. Now where is 0, 0? 0, 0 is on the outside. So if 0, 0 works, I'll shade on the outside. If 0, 0 doesn't work, then I'll shade on the inside. So my test point, TP, is 0, 0. Plug in a 0 for y and plug in a 0 for x. And we want to know, is that true or false? So is 0 greater than 1? No. So this is a no. So we don't shade on the outside, we should shade on the inside. So parabolas, make a table. All right, letter C. How would we graph 5x minus 3y. Again, pretend we have an equal sign. And that's just going to be a line. Some of y'all would take the time to put it into y equals mx plus b form. I'm just going to go ahead and do the intercept method. So to find the x-intercept, I let y be 0. So my x-intercept would be -3. To find my y-intercept, I let x be 0. So I get y being 5. Now will this be a solid or will it be a dotted line? It's going to be solid because it was greater than or equal to. So we're going to have a solid line. And then we have to figure out where we shade. So again, we'll do a test point. 0, 0 is right there. So my test point would be 0, 0. Plugging in x being a 0, plugging in y being a 0, I want to know, is that true or false? So that says 0 is greater than or equal to -15. That is true. 0 is greater than the negatives. So I'll shade where 0 is. So I'll shade down below. Lastly, let's make sure we also remember how to graph circles. This is a circle because both are being squared. We know that our center comes from the opposite and the opposite, changing your sign, changing your sign. So 1, -3. And this is our squared, so the radius would be 4. So we're going to have 1, -3, and the radius of 4. So 2, 4, 4 to the right, 2, 4, 4 up, 2, 4, 4 left, and 2, 4 down. Now, is it going to be solid or dotted? Well, it's going to be dotted. Why? Because it's strictly less than. So now you get to draw a beautifully dotted circle. Now where is 0, 0? It's here. But you know what? 0, 0 is not my first choice. I'm plugging in a test point for circles. My first choice for circles would be plugging in the center. Because if I plug in a 1 and a -3, I already get zeros. So my test point for circles will be the center, 1, -3. If I plug in a 1 here, 1 minus 1 is 0. When I plug in a -3 plus 3 is 0. And I want to know, is that less than 16? So is 0 less than 16? Yes. So I'll shade in between, or inside the circle. So a couple of different ways to do it, but I like to look at my center when I have a circle. All right, so that was just some practice of graphing lines, parabolas, and circles. Now let's get into actually graphing a system. So, systems of inequalities. A solution of a system of inequalities in x, y is a point that satisfies each inequality. So how are we going to do this? Well, we're going to sketch each individual inequality, and then we're going to see where the shading overlaps. So we're going to sketch each individual inequality, and then we're going to see where the shading overlaps. So where is the region that is in common in the shading part? So sometimes multiple colors help, map colors, highlighters, those kind of things. So you can kind of see where all these things overlap. So let's look at number 3. Sketch the graph and label the vertices. We'll talk about what the vertices are. This book doesn't ask for the vertices, so I won't be asking for that on the test, but I do want to point out what those are. All right, so the first equation, because we're going to change it to an equal sign, is 3x plus 2y equals 6. But again, I would highlight inequalities, make sure you understand should they be solid or dotted before you graph them. So again, this is just a line because that power is a 1. So I'm going to cover up my y, my x-intercept would be 2. I'm going to cover up my x, so my y-intercept would be 3. If you want to put it in y equals mx plus b form, that's fine. But again, I like to do the intercept method because it goes a little bit faster. Should be dotted because it's strictly less than. So make sure you do a dotted line. Now where will we shade? Well, we'll look where 0, 0 is, which is below, and we'll see if it satisfies the original inequality. So 3 times 0 plus 2 times 0 is supposed to be less than 6. Is that true or false? So 0 is less than 6, that is true. So we know we're going to shade this direction. Now I wouldn't do a whole lot of shading, I would just put a few lines so we know where we're looking at. Now that means nothing is ever going to happen over here. So what is equation 2? Equation 2 is x equaling 0. That would be a vertical line, and it's going to be dotted as well. So we're going to have a dotted line. 0 because we went through 0. So now we have to use, say, 1. So if I plug in a 1, is 1 greater than 0? Yes, that's true. So we know we're going to shade this direction. But as you can tell, right now, by looking where do the purple and the red overlap, is just right in this area. So nothing over here is going to work, and nothing over here is going to work because there's not red and purple in the same location. All right, equation 3 is y equaling 0. Again, we pretend we have an equal sign. Y equaling 0 is just your horizontal line, again going on the x-axis. Because we went through 0, we can't use 0, so let's use 1. Is 1 greater than 0? Yes. So since 1 is greater than 0, we know we're going to shade above. So we now got to figure out where do the red, blue, and purple all intersect. And they're all going to intersect in this little space right here. So if you go into business, you're going to hear something called a feasible solution space. And your business has constraints. And your constraints say if you stay in this area where everything is shaded, your business is going to thrive. But if you get out of that shaded region, then your business will start to lose money. So this is going into, if you're going into business, you will definitely see this again. These are called constraints. You also have vertices. The vertices are what creates your closed space. So like 0, 0, 0, 3, and 2, 0. And then you'll use that to maximize your profit and minimize your cost and all kinds of stuff. So right now we're just making sure we can graph them. So don't worry about feasible solution spaces or vertices or anything like that. But I did want to point that out to you because if you are going into business, you will see this again. All right, so let's go ahead and skip B. If we have time, we'll come back to it. If not, it's just another problem, so we're okay. You don't have to do that one if you don't want to. All right, let's look at C, D, and E. So looking at C, again, I would highlight to make sure you remember should be solid or dotted, and those are definitely going to be dotted. Let's look at the first equation, which is x squared plus y squared. Pretend you have an equal sign, and so that's going to be our first one. So that's just a circle. Where are we centered at? We are centered at 0, 0, and the radius is 5. So centered at 0, 0, 5 to the right, 5 up, 5 left, 5 down. Solid or dotted? Well, going back, we see that it's strictly less than, so we know it's going to be dotted. So have a nice dotted circle. You can draw a solid circle and then erase if you don't like to try and draw a dotted one. So I could try 0, 0, that's my center, and if I plug in a 0 and a 0, is 0 less than 25? Yep, so we know that we're going to shade on the inside. So now looking at the second inequality and changing it to an equal sign so we can pretend we have an equal sign. The second one's going to be 4x minus 3y equals 0. In the past, my x-intercept would be 0, my y-intercept would be 0, so I only get 1 point. So once in a while that method fails, and the method failed there. I only get 1 point, so I need to find another point. So I'm going to go ahead and put this into y equals mx plus b form. So I'm going to subtract over the 4x, and I'm going to divide by -3. So I end up with y equaling 4/3 x. So that means I would begin at 0, then I would go up 4, or I could go down 4, left 3. Solid or dotted? It's going to be dotted. Because it was strictly less than. Again, I can't use 0, 0 as a test point because of so what I need to do is choose another test point. A lot of students when I'm in my face-to-face class will say 1, 1. That's too close to my line. I'm not sure where that really is. So my test point, I'm just going to choose something kind of far away, and so I'll just say 6, 0. So my test point is going to be 6, 0. So plugging it into here, 4 times 6 is 24, minus 3 times 0 is 0, and I want to know, is 24 less than 0? No. So this is a no, so that means none of these work. So where should I shade? I should shade above my line. So then, where do the red and the blue overlap? It's going to be in this half circle. And that's where I would darken. Make sure that when you do this on the test, you have some graph paper already out, or you've drawn some graph, a nice coordinate plane, and make sure you darken where you're going to be shading so I don't have to guess where you are wanting it to overlap. All right, so let's look. I'll go ahead and just circle D for you to try if you want to. Those are just going to be 2 lines. Just to give you a hint, your shading is going to be up on top. So maybe we'll come back to that one. Let's look at E. We have x squared plus y squared is less than or equal to 16, so that's going to be solid. The next one's going to be solid, but then the next one, the last one's going to be dotted. So let's look at the first inequality and make it into an equation. So that's going to be x squared plus y squared equals 16. Again, we pretend we have an equal sign. My center there is at 0, 0, and my radius is 4. I know it's a circle because of both of them being squared. Since 16 is r squared, I know r is 4. So 0, 0, 4 to the right, 4 up, 4 left, 4 down. Because it's less than or equal to, I know it's going to be a solid circle. I don't have to worry about dotting at this time. Then I do a test point to see where I shade. I'll try 0, 0 because it's my center. So 0 squared plus 0 squared is supposed to be less than or equal to 16. And that's true. So I know I get to shade on the inside. Again, don't do a whole lot of shading, just know that it's going to be on the inside. Alright, so inequality number 2, but changing it to an equal sign, we get y equaling x squared minus 3. Again, if you're not sure what that looks like, do a table, -2, -1, 0, 1, and 2. Don't worry about doing transformations, just plug it all in. It is 1. -1 squared is 1, 1 minus 3 is -2. Then you'll get -3, then you'll get -2, and you'll get 1. So -2, 1, -1, -2, 0, -3, 1, -2, and 2, 1. Whoops, sorry, 2, 1. So then we see we have a parabola, and it's going to be solid. And then we need to check. I think I went down too far. Oh, I did. My bad. That should be there, not down there. So excuse that last point. That is way too low. So let's go ahead and I'll show you the original. I'll show you the final one without that there. So then go ahead and do our test point. Our test point is going to be 0, 0. Plugging in a 0 and a 0, I get 0 is greater than or equal to 0 squared minus 3. So I want to know, is 0 greater than or equal to -3? And it is, so I know I need to shade inside my parabola because 0, 0 is inside. So I'm going to shade inside. So hopefully you'll see right now that where the purple and the red are overlapping is inside the circle and inside the parabola. Again, that piece is not there. And then inequality number 3, changing it to an equal sign would say y equaling 2. So we're going to have a dotted line at y equaling 2. We can try 0. Is 0 less than 2? That's true, so we know we need to shade below that line. So where do the parabola, the circle, and the line all intersect is going to be right here. So that is where you should darken. Remember, that's not supposed to be there, so you'll darken this area. So, better picture would be that. So that's what it should look like at the end. Alright, so just so you know what D should look like if you tried it, or going to try it, that's what D should look like. We have x minus 2y is less than -6. So again, I went ahead and did the intercept method, and so that would be my red dotted line. And then y is greater than -9, and I put it in y equals mx plus b form because my intercept method did not work so well, just because it had fractions. So then I'll start at 3 and then go up 5 to the right 3, or down 5 to the left 3, and there's my blue. And then where do they intersect? In that area right there. So, and then on the previous page, just in case you want to try it, if you don't, that's fine. I said, you know, you might want to try this one right here, Well, that's what it's going to look like, which is really different. So you had a parabola that faced down, you had a vertical line and a horizontal line, and then this was shaded and this was shaded also. So this is kind of split between two different shading points. So if you want to try B, you can. I probably would not give one like that to you on the test. The ones I would probably give you on the test would be something like E and maybe something like D and C. So there are the answers to section 5.5. Let me know if you have any questions.